Okay, so just going over this Pythag and Trig homework. Right, so whenever you've got a right angle triangle, you should be thinking of Pythag or Trig. If there's no angles involved and just sides being used, then you should be thinking of Pythag. So label the sides. C is the most important one. It is opposite the right angle. That means A and B can be either side, and it doesn't matter which one is which. Now his formula states that A squared plus B squared is equal to C squared. So X is the dimension there, squared, plus 16 is for B, squared, and C is being replaced with 18 and squared. Now we don't want this on this side, we want to leave X squared on its own, so X squared is equal to get rid of that, we minus it from both sides, or pick it up and throw it over, it changes sign. So in other words, you've got 18 squared, take away 16 squared. And to undo squaring, you square root it. So X is the square root of 18 squared, take away 16 squared. So X is, on the calculator, it is the root of 18 squared, take away 256, and that is 100% accurate. It's a surd. Now we haven't done these, but that's an example of an irrational number. It goes on forever, and there's no, the decimal it creates, there's no pattern to it, no recurring pattern. So when the calculator does that, that's less accurate because it's had to truncate it. There's no pattern it forms, so that's less accurate. But I want it to 1 dp, so it is 8.2. So I'm happy for that at the moment. 8.2. The units are meters, and it is to 1 dp. Okay, so I am checking that all the units have to be in meters. So I'm checking the, as I did, I didn't say it there, but it must. If these were meters, centimeters, it wouldn't work. You'd obviously have to convert them to the same units. It wouldn't matter which units you chose, meters or centimeters. It'd still work out. Right angle triangle. There's an angle involved, so it's trig. So we've got to use O, A, and H. So this is O, this is A, and this is H. Now the only two being involved are these two. So you've got to decide which ratio it is. So some old hag came and had tea one afternoon. And you can see that O and A is only that one there, the tan. So write down the rule first. So tan theta is equal to opposite over adjacent. At this stage we substitute in. So tan theta, well that's 34 degrees, is equal to O, well that is X, and that is divided by A, which is 28. Now to rearrange this, to undo this, to get X on its own, to cut this division by 28, you times through by 28. So X is simply equal to 28 multiplied by the result of tan 34. So X gives us, so 28, I don't need the times here, I can just type tan 34, close brackets, equals, and to 1 dp it is 18.9, so it gives you 18.9, and it's in meters, so that length there is in meters to 1 dp. Okay, so there's the answer for question 2. Question 3, again, there's an angle involved, so it's trig. This is opposite, this is hypotenuse, this is adjacent. So we're using these two here, which is going to be O and H is sin. So sin theta is equal to opposite over hypotenuse. Substitute in. Sin theta is equal to opposite, which is 21, over hypotenuse is 28. Now to cut this away, to leave you with theta and throw it over here, it becomes sin to the minus 1. So theta is equal to, once it goes over there, is sin to the minus 1, and the proper name of that is arc sin. Okay, I've shown that in a previous video. Arc sin of 21 over 28. And therefore theta to 1 dp in degrees is shift sin to engage the minus 1. And I can just do this as a fraction or a division. I'm going to do division. 21 divided by 28, and it is equal to 48.6. So 48.6 degrees to 1 dp. Okay, question 4. Now, when you're trying to find the length between two coordinates, there's two ways of doing it. I can't remember if I've shown you the shorthand, but I'm going to show you the long-winded way because we've got 3 of these questions coming. I'll do the long-winded way here, then I'm going to show you the shortcut on the second one, and then use the further use the shortcut on the third one, show how easy it is. Okay, for the long-winded way, you do a sketch, okay, of the axes, that's x and y, and you just roughly locate these. So that is -10 and 5. So there's the coordinate A just there. Coordinate B is 7 across, just very rough, it's not to scale, and 12 is up there, and that is coordinate B. Now we're trying to find the length going from here to here, so we're drawing that up, and as I've shown you with this sketch before, you just drop a vertical stone from the highest point, and from the lowest point you meet it like that to form a right angled triangle. Okay, right, so to finish this off, I know that the distance from here, the y-axis, to here is 7, so that length there is 7. The distance from the y-axis to here is 10, so I know that this distance is 17. That length from here to here is 17 units long. Similarly, the distance from the x-axis to here is 5, and the distance from here to here is 12. So I'll do 12 take away 5 gives me this length just here, and 12 take away 5 is 7. Now to find this length here, you can see we've got a right angle here. It is Pythag. This is got to be side C. I'm going to just change my colour again. Okay, this is side C. I'm going to call this side A and this side B. We've got A squared plus B squared equals C squared. A, 7 squared, plus B, that is 17 squared, is equal to C squared. So to undo squaring this to give you C, you square root both sides. So C is the square root of 7 squared plus 17 squared. So C is equal to 1 dp. We've got the square root there of 7 squared plus 17 squared, and that gives you that there. That's 100% accurate, as I've said, but we want it to 1 dp, which is 18.4. So it's 18.4, we'll do it again, units to 1 dp. Okay, so that's the answer for that one there. Question 5. Right, this one here, we've got right angle triangle, an angle involved, so it's trig. This is opposite, this is adjacent, this is hype. You circle the ones you know and need to know. O and H again is sin, so sin theta is equal to opposite over hypotenuse. So sin of 61 degrees is equal to opposite, which is our 38, over our hype, which is x. Now I've shown you in a previous video, when x is on the bottom here, to unravel it, to get rid of it, you bring this up and bring the entirety of that down. You interchange them. So x gives you 38, and it is divided by the result of sin 61. So x is equal to, calculator, 38 divided by sin 61. So 61, close brackets, equals, and to 1 dp I get 43.4. So 43.4, and it is in meters, and it is to 1 dp. Okay, question 6. Again, we've got just lengths involved, and therefore it's Pythag. So this is side C. I can call this side A and this side B. So he said that A squared plus B squared equals C squared. Okay. Substituting in A, well, I've got that as 18 squared. B, I've got that as 27 squared, and that gives us C squared. So C is equal to the square root of 18 squared plus 27 squared. C equals, so I've got square root of 18 squared plus 27 squared equals, and again 100% accurate, we want the rounded up answers, 32.4. So 32.4, it's in meters and it is to 1 dp. Okay, question 7. Right, we're back onto trig again because we've got an angle involved. So this is opposite, this is adjacent, this is hype. Circle the ones we know and need to know. So we know those two. O and H is sin. So sin theta is equal to opposite over hype. Substitute in. So I've got sin theta, which I don't know, is equal to opposite is 27 over hype is 36. And as I've said, to cut this away and throw it over, it becomes arc sin to the minus 1. Of 27 over 36. So to 1 dp, just simply going to work that out. We've got shift sin to get sin to the minus 1. 27 divided by 36, close brackets, equals 48.6. So it is 48.6 degrees to 1 dp. Okay, that brings us to question 8. And as I said, we've got another one of these questions, so I'm going to generalize it. And I can't remember if you've seen this, but here we go. To generalize it, you've got the x-axis, you've got the y-axis, and we're going to pick 2 points, point A and point B. Point A is going to have coordinates, x coordinate, we'll call it 1, y coordinate 1, and B is going to have coordinates x coordinate 2, and we'll just generalize it, call it y coordinate 2. So we're after this length of line just here, from here to there. So as we've done before, just drop a stone from the highest point, which is just down to there like that, and the horizontal to meet it like that. Okay. Right. So if I just change colour. Now in a similar vein, the distance from here to here is x1. The distance from here to here is x2. So the length here to here is simply x2 minus x1. So x2 minus x1 is that length just there. Okay, so we've got this length from here to here is x2 minus x1. From here to here is y2, is the y ordinate, and from here to here is the y1. So it is y2 minus y1, okay, is that length just there. So as Pythag said, a squared plus b squared equals c squared. We've got a, well, let's call this my a, this my b, and this my c. A, well, that is the length x2 minus x1, and we've got to square it, plus b, well, that's my length y2 minus y1, and we've got to square it, and that gives you c squared. Okay, which I'm going to call c is length a to b. So a to b squared. So I now know that a to b, and to undo this you square root, is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And that there is the general formula. That's well worth, well, certainly make a note in your books of it, because I'm going to be using that here and again in another question later on. So we don't need to draw any sketches from now on. We can just plug this information into here. So here we go. We have got, I'll show you how to use it now. If we call this coordinate 1 and call this coordinate 2, then what the formula says is the distance P to Q, it doesn't matter which one you call 1 and 2, I could have called this 1 and this 2, it doesn't matter, is equal to the square root of x2, that is the second coordinate, and there's my x. It is minus 5, take away x1, well that is my coordinate 1, and there's my x coordinate of coordinate 1, so it's minus 18, I've got to square it plus y2. y2 is the second coordinate, and this is the number there, 10, the y ordinate. Take away y1 is my minus, coordinate 1, and the y ordinate is minus 7. So I've got to square the answer, and I end up with PQ is equal to the square root of, and don't forget, double negative can be replaced with a positive, and there's also double negative here replaced with a positive. So I end up with minus 5 plus 18 gives you 13, and you've got to square it. And 10 plus 17, 7 is 17, and you've got to square it. And there's the answer. So PQ is simply equal to that there. So root of 13 squared plus 17 squared is equal to, and that's 100% accurate, and there's the rounded answer, is 21.4 units again, because we don't know what the spacing is, 1 dp, and that's the answer without having to do a sketch. That is the generalization, so from now on we can just use this formula. Okay, right, next question. It says calculate its area. Well, these dashes signify that this length is the same as this length, which means that this is an isosceles triangle. Now, what we tend to do here is we're going to need to know the height and the base. Okay, so we need to know the height and the base to work out the area of this triangle. Half base times, base times height divided by 2. So what I've got here is I'm going to draw this triangle out just here. There's a right angle just there. Okay, so drawing this triangle out over here, I end up with here is 15 degrees. Okay, and the height here, this is 26, and the height here is what I'm after. Well, I'm after that first of all, and I'm after that second of all. Okay, and there's a general formula for this, of which I'll show you in after I've done this. Okay, so I end up with working out the base. Well, now I'll do the height first of all. So labeling this, I'll just change my color. This is right angle just here. This is the hypotenuse. This is the adjacent. This is the opposite. Okay, I'm only using, because I'm trying to find x, this and this, so it is cos. So cos theta is equal to adjacent over hypotenuse. So cos of 15 degrees is equal to adjacent, which is x, over hypotenuse is 26. Bring that up, x is equal to 26 multiplied by cos of 15. Okay, so we get a length there of 26 cos 15, close brackets, equals, okay, real nasty surd there, and it gives you 25.11, 25.11 dot dot dot. We're not going to round up, we're going to use that in a bit. Okay, so I'm going to store that as A, and that is in centimeters. So centimeters. So store that as A, shift stow A, okay, and gone. Right, now I'm going to work out, that's what x is, I'm going to work out what y is. So just over here, y, well, that, if I change the color again, back to black, that there and that there is being used. Okay, so it's O and H is sin. So sin theta is equal to O over H, which is sin theta is 15, O is y over H is 26. Bring this up, y is equal to sin of sin 15, sorry, 26 times sin 15, and that's what we get for that. So y equals, and calculator, so 26 times by sin 15, so sin 15 brackets equals, and that gives you 6.7 6.72 dot dot dot, so I'm not rounding, centimeters, and that will store as B. Now what we know is you've just worked out this length here is y, so the entire base is going to be double that. Okay, so I'll need to double that, and it will be base times height divided by 2. So it is 2 lots of your base, which is 6.72. There's the base, times by the vertical height. There's the vertical height. I put 3 dots there. 25.11 dot dot dot. So that is your base, entire base, times by the height, and we're going to divide all of that by 2. Okay, and that's what the area is. So we end up with, let's store that as B. So shift stow B. I've got fraction 2 lots of B, alpha B. So 2 lots of my answer B multiplied by my height, which is A, alpha A. I don't know the times there. I could have written 2AB, all divided by 2, and that gives us an answer of 169, and it is centimeters squared, and that's the full answer. Now there is a formula. You have already been shown that area of a triangle is base times height divided by 2, which we've used here. There are 2 others. You can use Hero's formula, which is a weird one. Okay, so that's way 1. Hero's formula says that you need to get a constant S, and you only ever use this very rarely when you know all 3 lengths. We don't on this occasion, so we wouldn't use it. But S is simply the 3 sides together added up. Let's call them side A plus side B plus side C. Divide the answer by 2. That is how you get your constant S. And then the area is worked out by doing the square root of this S, wherever this number is, multiplied by the difference between S and side A, times by the difference between S and side B, times by the difference of S, take away side C. So 4 things times together, dirt, 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 and dirt. Square root it, and that does that. You'd only use that if you've got all 3 sides known. So there's one way, which is the very basic way, Hero's formula, and I've run out of space, so I'm going to rub those out because there is another way. And this one, it is worth remembering. Okay, I'll come on to a proof later on in the year. Area equals a half AB sine C. Now what this actually means is A and B are these 2 sides just down here. This only works if you know these 2 sides and an angle, any angle between. Okay, so it is equal to a half times A. Well, this side here is 26. It just so happens it is the same as B. They don't have to be, this side here. Times by the sin of the angle between them. The sin of the angle between them is 30 degrees. Okay, so I can work all that out and it will give me a nice answer. As you can see, it is 0.5, which is a half, times 26 times 26 times sin 30, and that will give me the answer straight off as 169, as you can see just here. Okay, so you could have used that, but you've never seen it. Okay, it only works for any triangle where you've got random, doesn't have to be a right angled, as long as you know this angle here. Let's say it's 40 degrees, and you know this length here is, I don't know, 17 meters, and this length here, let's say, is 10 meters. Then using this formula, it only works if you know a side and the angle between. Using this formula, the area would simply be half AB sine C, half A, that's one side, times the other side, 17, times by the sin of the angle between them. You work that out and it would work out the area of this triangle. Okay, right, next question. Question 10, work out its volume. Well, it's a prism. Now the weird thing about prisms, as I've told you many times before, is if you work out the area of the front face here, it tells you, the area tells you how many cubes are in the front layer. So in that very front layer, it will tell you how many cubes there are, and then you just times it by how many layers you've got, and that works for any prism. Work out the area of the face that runs through it, as long as it doesn't change its size and it stays the same, congruent. Then you just times by how many layers you've got, 15 layers. So the first thing to work out its volume is, I'm going to work out this area. So the area of the triangle is base times vertical height? Well, I don't know its vertical height, so I'm going to need to know this. I do know this, and I do know this, so it's going to be Pythag. So change my color. I'm going to call this my A, this my C, because it's opposite the right angle, and this my B. So rub this out. I might as well do this first of all. A squared plus B squared equals C squared. A, well, that is 18 squared, plus B, well, I'm going to leave that as B squared, is equal to C, well, that is 25, and I've got to square it. Now, to get that on its own, I've got to pick this up and throw it over, or take it away. So B squared is equal to whatever 25 squared take away the result of 18 squared is. And B is the square root of that answer, 25 squared, take away 18 squared. So B, you never round up halfway through a question, so we're not going to round up. Work it out. We get the square root of 25 squared, which is 625, take away 18 squared, which is 324, okay, squared is equal to, and there's 100% accurate, and there's the rounded answer, 17.3 ... It's not the final answer, so we wouldn't dream about rounding. It's meters. But we are going to use that now because I know that the height of this triangle is there. It is base, it is 18. So the area is now base, which is 18, multiplied by the height, which is 17.3 ... to show we're not rounding, divided by 2. So the area is equal to, there's our, don't have to store it because it's already there. We've got 18 times the previous answer, all divided by 2. And that gives us there, which is 156.1. So 156.1 ... It's not the final answer. That is meters squared. And that tells you how many cubes there are. So finally, therefore, the volume is equal to how many cubes are in the front layer, 156.1 ... multiplied by how many layers we've got. We've got 15 layers. So times by 15. This is the final answer, so we can round it. So times that by 15, and we end up with 2342.2. 2342.2, and it is meters cubed to 1 dp. Okay, and just check we can write that down, 2342.2. Yep, and that's the answer for that one there. Okay, it's a prism, triangular prism. Question 11. Now we've got to calculate its area. Now, a trapezium, the area is equal to little a plus little b. These are the parallel sides. Added together, divide the answer by 2 and times it by the vertical gap. There's the vertical gap between them, times by the height. Well, we know this length, we know the vertical height, we just don't know this. So we need to work this out. The only way you're going to work this out is if you drop a vertical down here and realize that that is 17. We've got a right angle, so we need to find this length here. So I know that this is 16, so I know this is 16. So there's only sides being involved, and I've got to find this length here. Let's call it x. So Pythag, only sides involved, Pythag. This is C, this is A, and this is B. So I've got A, well, I'll just do it underneath here. A squared plus B squared equals C squared. So I end up with A, which is 16 squared, plus B, which is x squared, equals C squared is 21 squared. Now to get that on its own, I've got to get rid of this, so take it away. X squared equals 21 squared, take away 16 squared. So x is simply the square root of 21 squared, take away 16 squared. And again, it's not the final answer, so we're not going to round. Okay, so calculator, we've got 441 take away 256. So the square root of take away 16 squared is equal to, there's 100% accurate, and there it is. In fact, I'm going to leave it like that. No harm in leaving it like that. Root 185, it's a lot neater, 185. So the length is that. So that is that length there. Now don't forget, that length there, the entire length, I need to add 17 to it. 17. So here we go. The area, well, add the two parallel sides. One of them is 17 plus The other one is 17 plus this, so 17 plus root 185, all divided by 2, and then times by the height between them. The gap between them is 16. So that's all I've got to work out on the calculator to get my answer. So I've got, I might use a brackets and a fraction button. I've got 17 plus 17 plus my previous answer, all divided by 2, come out, close brackets, and then times by 16. And my final answer for the area will be 380.8. 380.8. The lengths are all in meters, so it is meters squared to 1 dp. Okay, so that's that one there. Question 12, right, it's another occasion where we can use this formula. Don't forget the length between x and y, the length xy, so it saves us having to sketch this now. We can use this formula, is going to be x2 minus x1 all squared plus y2 minus y1 all squared. And it doesn't matter which one you call 1 and 2, I don't know. Let's call this 1 for a change and this 2. Now you've got to get this in the right order. You've got to be very careful here. So x2, well, I hope you've realised that is 12. Take away x1, that is minus 5. All squared, don't forget. y2, well, that is minus 7. Take away y1, well, that is minus 12. All squared. Now don't forget double negative. They won't always be double negatives, but it is there. And it is there again. Okay, so it's replaced with a positive. So it is equal to the square root of 12 plus 5 is 17 squared, plus minus 7 plus 12 is going to give you 5 squared. So it gives us, calculator, the root of 17 squared plus 25 equals, I think it's the same answer as, no, that's 17.7. So 17.7 units to 1 dp. Okay, it says having to do a sketch just using this formula. Right, nearly there. Question 13. We've got a right angle triangle, an angle involved, it's trig. This is opposite, this is adjacent, this is hype. So circle the ones you need to know and know. And O and H is sin again, so it is sin theta is equal to O over H. Substitute in sin theta, well that's 71 degrees, is equal to O, which is 83 over X. Now remember, X on the bottom, only when X on the bottom we interchange all of this and bring it down. So X is simply 83 over sin of 71. So X is equal to, okay, 83 divided by the sin of 71. Sin of 71, close brackets, equals, and I get 87.8. 87.8, and the units are meters to 1 dp. Okay, question 14. Again, a right angle triangle, angle involved, so it's trig, that's opposite, that's adjacent, that's hype. So we're involving that and that. O and A is tan, so tan theta is equal to opposite, which is going to be 14 over adjacent, which is 20. To cut that away and throw it over there, we arc tan both sides. So we've got theta is equal to arc tan is written to tan to the minus 1 of 14 over 20. Yeah, you could simplify that to 7 over 10, whatever. Okay, but it's not the final answer, so it doesn't matter. We've got shift tan of 14 divided by 20. Close brackets, and there it is. Now to 1 dp, this becomes a 10. You can't have a 10, so it's 35, and you do need the 0, 35.0. So theta is 35.0 degrees to 1 dp. And that brings us to the last question. Now, only sides involved, so it's Pythag. So this is the important one. It is C, this is A, and this is B. So it says that a squared plus b squared equals c squared. A, well, that is my x squared plus my b, which is my 2.6 squared, is equal to my 4.7 squared. Now I'm trying to get this on its own, so I can't have this. It's got to be thrown over and becomes a minus, take it away from both sides. X squared is 4.7 squared, take away 2.6 squared. So x is, to undo it, we square root. It's a square root of 4.7 squared, take away 2.6 squared. And again, the units are in meters to 1 dp. It's a length. Okay, so all I've got to work out is the square root of 4.7 squared minus 2.6 squared, and we get 3.9. So 3.9 meters to 1 dp. Now I'm looking at this and I've got to make sure that that is the longest side, yeah, and that is 3.9. So yeah, it's longer than any other side. So yep, and there's the final answer. Okay, and that is it. I hope that helps.